I guess it is time for another update. So you can immediately see blue Ed Core things sitting on the bench. They said 4 to 6 weeks delivery. Try three. Three from the day I ordered to the day it was at my door. So the transformer here on the left is a custom built power transformer to my specifications. Really cool. And then that is their 10 Henry inductor. So big choke. But before we get into any of that, look at that. I bought myself an isolation transformer because I wanted to follow again safety guidelines and safety ideas, and so this completely removes ground from the picture while I am trying things out. So you can see that it is very old. I bought it on eBay, but it has no ground plug spot. There's no spot for that terminal to go on this, and that's not because it's so old. That's because that's what it does on purpose. It is designed to isolate your neutral from the house neutral, and then there's no ground at all. So if you were to accidentally inadvertently bump into something as you're working, this reduces the chance that you will become the pathway to ground and murder yourself. I don't want to murder myself, so not today at least. The other big thing you probably see here is I bought myself a Variac. I bought a beefy one, and so I'm pretty excited about that. Another thing you might see is this power cable here. I've made my own power cables. I was recently gifted some wire, and so I thought, hey, let's do this fancy. Since it's monoblocks, I'm actually probably going to set each amplifier on top of the speaker, so I do need some longish power cables, and that is some really heavy duty 10 gauge 10 stranded wire. You can see my IEC connector there that has RF in it. I think I mentioned that last time. I'm kind of showing you that, whether I intended to show you that right now or not. That is B plus for this amplifier, 500 volts. Pretty cool to see everything come up. One of the things that I might, and when I say come up, I mean I turned it on, I turned the Variac on, 0 volts, slowly bring things up to make sure nothing's going to smoke. Additionally, there is a delay circuit in this, but and it is quite long. I don't know if it was supposed to be that long. I'll probably go back and redo that calculation. But one of the things you'll see is that there's black wire or black tape on some of the wires. That's because when they sent the transformer, they didn't actually indicate which wire was common. In their drawing, they show that there's common. They're not actually tied together as a common, even though they call it common. But the way that you go about finding whether you're in phase or not, because you do need to know that, is you connect 2 of the windings on the output or on the power transformer together, make basically a virtual center tap, and then you know what voltages should be. So for instance, if I have the the brown wire and the yellow wire are both 6.3 volts AC, and so if they are in phase, that should add, so you should end up with 12.6 volts. If they are out of phase, then you should end up with 0 volts. So basically what you do is you go through and just connect 2 wires together and measure across them and see whether it adds or whether it subtracts. If it adds, then you did the right thing, and so that allows you to mark your ground wire or make a comment. So I've made essentially a comment here. I have tested things out. So the green light, don't remember what that one is. I think it means the 12 volt converter is converting. There's a red light down in there. You can see that. That means that the soft start relay has started. I actually kind of freaked out a little bit. I forgot about the soft start, and as I was turning up the transformer, the voltage really lagged on the output here. So you can see I've got a black wire connected to a common, and my red there connected to B plus. And so I checked everything out but B plus. I saved B plus for last. So I went through and checked to make sure my drive voltage was right, that my negative bias voltage was right, that so you can see the yellow and brown, those actually connect together. That makes I actually didn't measure what the output makes, but it runs then over to this DC to DC buck converter, which I will need to eventually load up and adjust so I can simulate the 5 amps of load that thing's going to see, and these two little brass screw terminals on top, those drive potentiometers, and that allows you to adjust the voltage and current. It's kind of cool. But yeah, the B plus, the starting it up, I forgot about this little relay, and so I'm cranking and cranking, and it's just not going up. And on the Variac, and I know I'm to the point where it should be going up, and it's just not. And then I was like, oh yeah, that's right, there's a soft start built into this. So yay, that works. Always worried that I've attached a capacitor backward. If you've ever blown up an electrolytic cap, that's kind of, they spray confetti. They can be kind of dangerous if they're big. So I definitely was careful starting things up and making sure that all worked properly. So anyway, super exciting. Here's one power board connected, checked out, working. This all works like it was supposed to. Yay. I don't know any other way to say it. And one of the things I guess I didn't do is I didn't make my ground, my short to ground, so that I can short things out. Now granted, there is a short there, that big resistor that you can see here on the edge of the board, that does short across B plus, so it will drain B plus, but some of these other caps might stay hot for a while, and that could be pretty dangerous, especially the negative drive voltage is 200 volts. Grab a hold of that, you'll know about it. I don't know about you, but I don't want to be the one who completes that circuit, so at least not with my finger. So yeah, B plus, 500 volts. There's just all kinds of deadly sitting there on that board. 500 volt, 200 volt. Either one of those, super fun. Make you tingle a little bit, more than a little bit. Really hurt. So anyway, I'm excited. I'll probably load some things down a little bit. I've got some resistors, and I'll load some stuff up eventually and check out to make sure everything provides current like it's supposed to. And we'll see what happens from there. So anyway, with that in mind, I'm gonna turn off the power, and you'll see there is a dropping resistor in there, but it takes it a while. That is a whole lot of capacitance there, and it's got to drain it. So yeah, if you turned that off and thought it was off and grabbed a hold of that board, yikes. So anyway, short update. Just lots of parts. Eventually we'll be painting the bell end bells here, painting those a different color. I've already got hardware ordered. We'll get rid of this silver that's not very attractive. I've got black oxide, but I don't know. We're thinking about maybe doing something different, maybe painting those too. I think I've elicited my wife into helping with design, which will be kind of fun. One of the things I think I would like to do is have a wooden frame for each amplifier. We have visited New Zealand a few times, love New Zealand, attempted to move there. If it wouldn't have been for COVID, I probably wouldn't be making this video in America right now. COVID kind of ruined a lot of things. I am still alive though, so I can't complain too much. But they have a tree called kuri, and the kuri wood is really known for its musical quality. The problem is that when those trees are young, they make really good ship's masts. So the kuri wood was almost completely obliterated on the islands of New Zealand, and it's only in New Zealand, and so it's hard to buy a kuri wood, except they have found where these big giant trees have fallen into swamps and marshes and were preserved. So you can buy old kuri wood, and so it's like 50,000 years old. We have a kuri wood bowl and a few other things, and so I'm probably going to make my frame out of kuri wood. I've got to find an American supplier. I think I've got one. So I'm pretty excited about that. So anyway, that's pretty much it.